When the United States ratified its Constitution in 1789, it inherited only scattered stockpiles of flintlocks, captured British muskets, and a handful of French cannon left over from the Revolution. George Washington's first Secretary of War, Henry Knox, warned Congress that dependence on European suppliers in a future conflict would be fatal. Congress responded in 1794 by creating a permanent ordnance department inside the War Department and by authorizing two purpose-built national armories, one at Springfield, Massachusetts, the other at Harper's Ferry, Virginia. These government factories served as pattern shops. They fixed technical standards, trained a native cadre of gunsmith engineers, and audited the quality of a small but growing web of private subcontractors in New England and Pennsylvania. Water-powered trip hammers, precision filing jigs, and gauge templates, copied largely from French artisan practice, laid the mechanical groundwork for interchangeable parts. Eli Whitney is best known for the cotton gin, but his deeper legacy for the military-industrial nexus began in 1798 when he signed a contract to deliver 10,000 muskets to the War Department, more than double the entire small arms output of the young republic up to that point. Whitney had to build a factory from scratch on Connecticut's Mill River. He equipped it with water-powered lathes and milling machines and introduced metal templates that promised manufacture without the aid of the human hand to guide it. Although he missed every delivery deadline, the project forced the War Department to articulate written tolerances, gauge blocks, and inspection routines. Whitney's efforts converged with the work of Simeon North, John Hall at Harper's Ferry, and later the Robbins and Lawrence Company in Vermont. By the 1840s, these firms and armories had established what historians call the American system of manufactures, a regime in which wooden stocks and metal lock assemblies could be swapped among rifle models with minimal hand-fitting. Government contracts, written as fixed-price and fixed-specification bids, turned the War Department into the nation's de facto standards agency. Pursuit of economies of scale led arms makers to develop machine tools whose application soon spilled into civilian markets, sewing machines, farm implements, even the first interchangeable part pocket watches. The Civil War detonated demand beyond anything antebellum contracts had imagined. Between 1861 and 1865, the Union ordered roughly 2 million rifles, 4,000 artillery pieces, and billions of rounds of ammunition. Federal arsenals could not keep pace. The War Department turned to private firms on an unprecedented scale: Colt, Remington, Smith & Wesson, and the newly formed Winchester Repeating Arms received contracts worth tens of millions of $1860. Colt lobbied Congress directly for patent extensions, while Remington bought newspaper advertisements hinting that delays in funding would cost Union lives. For the first time, arms makers employed dedicated Washington representatives, a nascent form of defense lobbying. The war also accelerated metallurgy. Pennsylvania foundries that had supplied wrought iron plate for gunboats consolidated into Bethlehem Iron, and Andrew Carnegie's mills in Pittsburgh pivoted from railway rails to heavy artillery tubes. When Carnegie merged with J.P. Morgan to form U.S. Steel in 1901, the world's first billion-dollar corporation, the structural symbiosis between heavy industry and national defense was firmly in place. After 1898, the political geography of ordnance shifted again. The Spanish-American War showcased rapid-fire artillery, smokeless powder, and naval logistics, prompting Congress to fund a new steel navy. Rear Admiral Alfred Thayer Mahan, promoted by Naval League advocates, argued that capital ships guaranteed both national security and stable industrial orders. Private suppliers like Bethlehem and Carnegie's Homestead Works co-wrote armor plate specifications with naval officers, ensuring a captive market. Meanwhile, the 1903 establishment of the Army General Staff and the 1907 overhaul of the Navy's bureau system formalized procurement pipelines. Even during the lean, isolationist budgets of the 1920s and 1930s, the Army Ordnance Department issued educational orders to keep factories warm. Springfield Armory ran small lots of the new M1 Garand rifle, and Bethlehem built prototype 14-inch turrets. Trade associations secured the Vincent-Trammell Act of 1934 and the Two-Ocean Navy Act of 1940, locking in naval aircraft quotas that resuscitated Boeing, Grumman, and Douglas before Pearl Harbor. By 1941, when Franklin Roosevelt called the United States the arsenal of democracy, every component of a modern military-industrial complex was in place. Federal arsenals still set technical baselines, but conglomerate steel and chemical trusts could surge capacity on credit secured by long-term Navy and War Department contracts. Trade associations and permanent Washington representatives translated industrial agendas into legislative language, while universities such as MIT and Caltech already enjoyed classified funding streams for radar and rocketry. The wartime escalation that followed fused these elements into the fully articulated system that President Eisenhower would eventually christen, and caution against, as the military-industrial complex. With the attack on Pearl Harbor in December 1941, the production infrastructure that had been quietly scaffolded during the interwar years flashed into high gear. Roosevelt's pledge that America would become the great arsenal of democracy translated within months into the largest industrial mobilization in human history. Washington revamped the modest Office of Production Management into the War Production Board, armed it with legal authority to allocate steel, copper, rubber, and machine tools, and staffed it with a revolving cadre of executives on temporary leave from Sears, General Motors, and Alcoa. Civilian automobile lines in Detroit were shut down within 60 days, the same plants retooled to stamp aircraft fuselage sections and tank hulls in volumes no European belligerent could match. A single Ford facility at Willow Run eventually rolled one B-24 Liberator off its mile-long assembly line every 63 minutes, proving that car industry flow production could be ported to four-engine bombers. The war also crowned a new hierarchy of prime contractors. Boeing and Douglas, which had previously built aircraft in artisanal batches, adopted mass production techniques pioneered by the automobile sector and supervised by Army Air Force's production missions. Lockheed Skunk Works, under Clarence Kelly Johnson, compressed design, prototype cycles from years to months while delivering the P-38 Lightning and, later, the first operational American jet, the P-80. General Motors, already a behemoth, coordinated 120 subsidiary plants to manufacture everything from Allison V-1710 aircraft engines to M4 Sherman tanks and M1 carbines. At one point GM alone accounted for almost 10% of all U.S. military procurement dollars. The federal government financed enormous new facilities: Chrysler's Detroit Arsenal tank plant, North American Aviation's bomber plant at Inglewood, under cost-plus-fixed-fee contracts that guaranteed contractors recovery of expenses plus a modest profit margin, a formula that minimized financial risk and encouraged rapid scale-up. Scientific research, once largely academic, became a strategic arm of the state through Vannevar Bush's Office of Scientific Research and Development. University laboratories were reorganized into quasi-military projects. MIT's Radiation Laboratory produced the microwave cavity magnetron that shrank radar sets from room-sized curiosities into airborne instruments, while the Applied Physics Laboratory at Johns Hopkins perfected the proximity fuse, hailed by Admiral Radford as the gadget that won the naval war. The most extreme fusion of science, industry, and government was the Manhattan Project. Under the Corps of Engineers District Manhattan, but effectively run by Bush and General Leslie Groves, it commandeered DuPont to build the Hanford plutonium reactors, Union Carbide to operate the gaseous diffusion plant at Oak Ridge, and the University of California to manage the Los Alamos Weapons Laboratory. In barely 30 months the project spent $2 billion 1940s dollars, employed 130,000 workers, and delivered a technological discontinuity that redefined geostrategic calculus overnight. By VJ Day in August 1945, American factories had turned out 300,000 aircraft, 88,000 tanks, 746 warships, and 41 billion rounds of small arms ammunition. The War Production Board controlled roughly 40% of the nation's industrial output, yet unemployment had fallen below 2% and corporate profits after taxes exceeded pre-depression highs. Perhaps most important for the post-war era, the procurement habits, contractor relationships, and university research contracts forged under emergency became normalized bureaucratic channels. The United States emerged not just with surplus material but with a permanently enlarged apparatus able to yoke scientific discovery, corporate scale, and federal finance into a single warfighting, and soon, Cold War, machine. With victory secured and wartime agencies disbanded, Washington faced the problem of preserving the command and control linkages that had proven so effective without sliding back into the fragmented procurement politics of the 1930s. The answer came in the National Security Act of 1947, drafted under the guidance of Navy Secretary James Forrestal and New Deal lawyer Clark Clifford. It fused the War and Navy departments into a single national military establishment, renamed the Department of Defense in 1949, and created both the Central Intelligence Agency and the National Security Council to integrate policy across diplomatic, economic, and military spheres. The aim, explicitly stated in committee hearings, was permanent preparedness in an age of undeclared war. Inside the new Pentagon, a uniform revolving door system of cost-plus and fixed-fee contracts ensured that Boeing, General Dynamics, and the rebranded Lockheed Aircraft Corporation could transition from piston bombers to jet aircraft without financial whiplash. The early Cold War amplified that logic. When the Truman Doctrine committed the United States to containing Soviet influence in 1947, military assistance packages flowed through the same corporate channels that had built the wartime arsenal, but now underpegged to a peacetime boom in consumer demand. The $13 billion European Recovery Program, better known as the Marshall Plan, cemented the dual civil-military circuit. Steel, aluminum, and machine tools shipped to Europe revived civilian reconstruction while simultaneously expanding the industrial base capable of producing tanks and jet engines for NATO. Commerce Department memoranda openly described dual-use leverage, noting that surplus Liberty ship engines could be adapted to power Marshall Plan dredging equipment, then reacquired by the Navy if mobilization returned. By the mid-1950s, appropriations data revealed a striking asymmetry. Although uniformed manpower fell from its World War II peak of 12 million to under 3, the defense budget stabilized at a constant 7 to 10% of GDP, far higher than the interwar average. Half of that outlay went directly to private contractors, whose government relations offices in Washington's K Street corridor quadrupled in less than a decade. Research universities were swept into the same orbit. Driven by Soviet atomic tests in 1949 and the Korean War in 1950, the Office of Naval Research and the newly created Air Force Office of Scientific Research funneled grants into microwave engineering at Stanford, semiconductor physics at MIT Lincoln Laboratory, and atmospheric modeling at RAND's spin-off Project Meteor. When the National Security Agency emerged from the Armed Forces Security Agency in 1952, it quietly contracted IBM and Burroughs for code-breaking computers, establishing the template for classified R/&D consortia that would later birth Silicon Valley. Dwight Eisenhower, himself a product of the General Staff system and no enemy of defense spending, nonetheless watched these developments with concern. Throughout his presidency he tried, ultimately in vain, to restrain service rivalry and what he called contract escalation, the phenomenon by which initial bids, secured on optimistic timelines, ballooned once firms became entrenched as sole suppliers. In private cabinet meetings he grumbled about galloping technology chasing its own tail. Yet political realities, from Sputnik to the Quemoy crisis, forced supplemental appropriations that locked in high-throughput production of Atlas and Titan missiles, nuclear submarines, and the sprawling interstate highway system, justified as essential for rapid military mobilization. On January 17, 1961, 3 days before leaving office, Eisenhower framed his unease in a televised farewell address. For the first time, a sitting president warned that an institutional symbiosis of arms makers, uniformed services, and appropriations committees could, if left unchecked, endanger our liberties or democratic processes. His phrase, military-industrial complex, gave the public a vocabulary for a structure that congressional hearings had documented only in budget line items. By then, however, the architecture was securely in place. The Pentagon occupied 5 million square feet, Texas Instruments was mass-producing infrared missile seekers, and research universities from Berkeley to Urbana were operating with defense overhead topping 20% of their science budgets. The complex had graduated from wartime expedient to permanent feature of the American political economy. Secretary of Defense Robert McNamara entered the Pentagon in 1961 determined to replace service parochialism with a mathematically rational war machine. Trained in systems analysis at Ford Motor Company, he imported the planning programming budgeting system, under which every weapons program was forced into cost-effectiveness spreadsheets populated by RAND Corporation algorithms. Air assault tactics in Vietnam became laboratory problems. Sorties, body counts, and sensor coverage were plotted on IBM 7094 mainframes inside the Pentagon's National Military Command Center, whose wall-sized screens updated kill ratios in real time. At RAND's Santa Monica campus, analysts ran Monte Carlo simulations predicting insurgent morale as if it were inventory decay. The promise was a data-driven war that could be tuned like a production line. The reality was that Viet Cong adaptation outran the metrics, but the computational infrastructure remained, expanding the symbiosis between defense planners and private think tanks. On the ground, the conflict elevated new hardware sectors. The UH-1 Huey, produced by Bell under contracts that ballooned from an initial 800 units to more than 11,000, turned vertical lift into a central doctrinal pillar. Hughes and Raytheon supplied infrared sensors, laser rangefinders, and the first mass-fielded anti-tank guided missiles. Texas Instruments' night vision scopes introduced solid-state imaging to infantry combat. Electronics now accounted for nearly 40% of all procurement dollars, and with it came soaring overruns. The F-111 swing-wing bomber breached its budget by 250%, while the Navy's Aegis fire control radar slipped half a decade behind schedule. Congressional hearings excoriated gold-plated avionics at the same time campus protests denounced Dow Chemicals' napalm and General Electric's miniguns, illustrating how the cost spiral and the moral backlash reinforced each other. Yet even as anti-war sentiment swelled, Pentagon research money transformed American universities into subcontracted idea factories. ARPA's Information Processing Techniques Office poured grants into MIT's Project Mac, Stanford's AI Lab, and the University of Utah's Graphics Group, demanding only quarterly progress reports and security clearances for key staff. In 1969, ARPA funded engineers at UCLA, SRI, UC Santa Barbara, and the University of Utah linked their time-sharing computers via interface message processors, birthing ARPANET, the germ of today's Internet, explicitly to guarantee command and control resilience after a nuclear strike. By the time Saigon fell in 1975, the United States had failed to secure South Vietnam, but it had embedded a digital nervous system in its own academic and industrial landscape, ensuring that systems warfare would survive the war that first inspired it. Stung by the perception of post-Vietnam malaise and the 1979 Soviet invasion of Afghanistan, the incoming Reagan administration embarked on the most aggressive defense build-up since World War II, expanding the Pentagon's five-year plan from an already hefty $1.5 trillion to more than $2.2 trillion in then-year dollars. At the program's ideological core lay the Strategic Defense Initiative, unveiled in a 1983 Oval Office broadcast that promised an impenetrable shield of lasers, space-based kinetic interceptors, and ground-launched miniature rockets capable of striking Soviet ICBMs in boost phase. SDI did not spring from mature technology. Most concepts lived only in Los Alamos slide decks or DARPA white papers, but it institutionalized a new funding model. Rather than place risky basic research inside government laboratories, the administration issued thousands of exploratory contract work orders to private firms and university consortia, each competing for incremental milestones. Lockheed's Missile and Space Company prototyped the homing overlay experiment. Martin Marietta explored chemical laser mirrors. TRW and Rockwell bid on Brilliant Pebbles autonomous interceptors the size of grapefruits. Taxpayer money thus underwrote high-risk technology while allowing companies to retain intellectual property rights, accelerating the long-term privatization of what had been state-owned scientific uncertainty. This surge coincided with a sweeping corporate consolidation. In 1975, roughly 50 prime contractors vied for the bulk of Pentagon dollars. By 1991, mergers, leveraged buyouts, and the absorption of specialized avionics houses had reduced that number to fewer than 15 giants. The largest inflection point came in 1985, when General Dynamics sold its Cessna division to fund the purchase of Chrysler's tank arm, while Northrop's acquisition of Grumman merged the Navy's two premier carrier aircraft houses. Wall Street rewarded these deals because larger primes could amortize the escalating cost of compliance with the Pentagon's increasingly complex cost accounting standards. As procurement officials leaned on multi-year contracts for the B-2 bomber and Seawolf submarine, financial analysts began describing defense equities as quasi-utilities, low growth but backstopped by federal demand and protected from foreign competition under ITAR export controls. Venture capital, newly energized by legislation like the 1978 ERISA revision, poured into spin-offs such as Laurel and SAIC that specialized in systems integration, cybersecurity, and classified software, cementing the service-oriented tier of the complex. When the Berlin Wall fell in 1989 and the Soviet Union imploded 2 years later, pundits predicted a peace dividend worth hundreds of billions. Congress did slash procurement outlays from $135 billion in 1989 to $58 billion by 1994, yet the anticipated civilian conversion never materialized. Giant primes shed workers. General Dynamics alone cut its payroll from 98,000 to 37,000, but they also absorbed rivals in a consolidation wave christened the Last Supper after a 1993 meeting where Defense Secretary Les Aspin encouraged CEOs to merge or perish. Lockheed swallowed Martin Marietta, Boeing absorbed McDonnell Douglas, and Raytheon bought Hughes's missile division, yielding the modern oligopoly of 5 superprimes. Meanwhile, SDI's research pipelines quietly morphed into new ballistic missile defense programs, and congressional committees directed residual funds toward dual-use initiatives like GPS modernization and DARPA's fledgling stealth unmanned combat air vehicle studies. In practical terms, the defense budget's share of GDP fell only from about 6% at the height of Reagan's buildup to roughly 3% by the mid-1990s, still double the Cold War baseline of the early 1950s. Thus the Soviet collapse failed to reverse the structural integration of private high-tech enterprise and permanent national security demand. It merely resized and streamlined a complex now optimized for leaner but continuous projection of American military power. The 1991 Gulf War functioned as a live broadcast infomercial for the revamped American defense industry. Cable news viewers watched laser-guided bombs snake down Baghdad chimneys, Patriot missiles intercept Scuds above Riyadh, and real-time logistics dashboards flash across Pentagon screens during daily briefings. In 43 days, U.S. and coalition forces fired 250,000 precision-guided munitions, more than had been produced in the entire previous decade, proving that the long investment in GPS, stealth coatings, and digital mission planning could translate into battlefield asymmetry. The war's operational tempo relied on innovations unseen by the public, logistics nodes built on radio frequency barcodes, satellite uplinks to the new Defense Information System network, and total asset visibility software coded by EDS contractors. For prime contractors, the conflict validated marketing claims. For export clients, it whetted appetite for the same toolkit. Requests under the Foreign Military Sales Program swelled from $13 billion in 1990 to nearly $32 billion by 1993, with Saudi Arabia ordering F-15S strike fighters and Kuwait signing for Patriot batteries almost before the oil well fires were out. Hopes that defense giants might pivot to civilian megaprojects, hypersonic airliners, magnetic levitation trains, or renewable energy turbines, largely fizzled. Boeing's commercial aircraft division indeed boomed, but attempts by Lockheed Martin to market wind turbine blades derived from submarine propeller research stalled, and Northrop Grumman's foray into medical imaging equipment evaporated once hospital budgets balked at defense-grade price tags. Instead, primes deepened subcontracting chains that allowed them to remain system integrators while shedding manufacturing risk. By the late 1990s, up to 60% of major weapons content, circuit boards, fuel bladders, composite fairings, was produced by second-tier firms that operated on razor-thin margins and wielded little lobbying clout, cementing a hub-and-spoke model in which a handful of primes brokered both technology and policy access. The Clinton administration, determined to keep allies militarily interoperable and U.S. plants humming, loosened Cold War export controls. The 1996 revision of the International Traffic in Arms Regulations shifted dozens of satellite components and avionics subsystems from the munitions list to the dual-use commerce control list, simplifying licenses for NATO and major non-NATO allies. Simultaneously, NATO's eastward enlargement opened virgin markets. Poland bought F-16CS bundled with offset agreements. The Czech Republic acquired Raytheon's upgraded Hawk air defense missiles. Hungary leased Gripen jets equipped with Lockheed Lantern pods. In Asia-Pacific, Australia signed onto the Joint Strike Fighter program at the concept stage, and South Korea inked deals for Aegis-equipped destroyers and Apache helicopters, hedging against a nuclearizing North while anchoring itself to the U.S. supply chain. By the turn of the millennium, the U.S. military-industrial complex had completed a full structural pivot from bipolar standoff to globalized security provisioning. Precision warfare had become a televised brand, subcontracting had displaced in-house fabrication, and export policy had fused with alliance management. Far from shrinking after the Cold War, the complex had reoriented itself outward, monetizing American technological dominance and embedding supply chains across an expanded security perimeter stretching from Warsaw to Seoul. The attacks of September 11, 2001 detonated a procurement, contracting, and legislative surge unmatched since the early Cold War. Within 3 weeks, Congress passed a $40 billion emergency supplemental, the Pentagon's Overseas Contingency Operations Accounts, OCO, a bookkeeping device that sat outside the regular cap system, rapidly ballooned to more than $187 billion a year. Astonishingly, more than 50% of that money bypassed traditional prime contractors and flowed through service contracts for logistics, intelligence analysis, base construction, and private security. At the center stood Halliburton's Kellogg Brown & Root subsidiary, holder of the multi-billion-dollar LOGCAP III contract, which built and ran FOB cities in Iraq and Afghanistan, complete with laundry, ice factories, Burger King concessions, and a fuel delivery system that charged the U.S. Army as much as $28 per gallon once convoy security and subcontract layering were counted. Simultaneously, private military companies like Blackwater, founded 1997 but catapulted by post-9/11 demand, won State Department and CIA task orders to guard diplomats, train Afghan commandos, and fly discreet Mi-17 helicopters over Pakistan's tribal areas. By 2007, the ratio of contractors to uniformed personnel in Iraq exceeded 1-to-1. At certain forward operating bases, the only government employees in sight were platoon leaders and contracting officers. This outsourced model coincided with a technological tilt toward networked warfare. The CIA's covert use of the MQ-1 Predator in Afghanistan during the first Robinson Ridge strikes of 2000 had been an experiment. After September 11 it became policy. Air Force pilots at Creech Air Force Base in Nevada logged 12-hour shifts flying drones over Helmand Province, while General Atomics Robotics expanded its Palmdale facility fourfold to keep up with Reaper block orders. Each aircraft's ISR feed traveled through Ku-band relay satellites owned by Intelsat and L3 Communications, creating a profit layer even in the spectrum itself. At CENTCOM headquarters in Tampa, officers stitched drone video, SIGINT intercepts, and human terrain data into the first kill chain databases, much of the backend assembled by Booz Allen Hamilton and SAIC programmers granted top-secret/SI clearances within months of hiring. Those same firms helped NSA implement StellarWind, which vacuumed domestic telephone metadata on the theory that social network analysis could reveal sleeper cells. When Edward Snowden, himself a Booz Allen contractor, disclosed the program in 2013, the scandal merely underscored how seamlessly the surveillance state had fused with for-profit cyber contractors. The newly created Department of Homeland Security replicated the pattern. Congress authorized more than $50 billion in 7 years for airport biometrics, radiation portals at seaports, and the now-defunct SBINet virtual fence along the Mexican border, a Raytheon-led project of ground surveillance radars and thermal cameras that spent $1 billion before yielding 68 miles of intermittent coverage. Lobbyists dubbed this spending the security gold rush, and Wall Street analysts began tracking an exchange-traded fund of firms whose revenue depended on government fear management. Meanwhile, the Pentagon's competitive source selection environment narrowed further. By 2015, a lockup of 5 superprimes, Lockheed Martin, Boeing, Northrop Grumman, Raytheon, and General Dynamics, captured 35% of all defense obligations, yet each prime's own revenue mix showed service contracting growing faster than weapons fabrication. Inside the Beltway, the revolving door spun faster than ever. General Peter Chiarelli joined One Mind Technologies to market neurotrauma diagnostics. Admiral Mike Mullen accepted a directorship at General Motors but also consulted for Raytheon on naval radar strategy. General Keith Alexander, fresh from running the NSA, launched IronNet cybersecurity and sold intrusion detection services back to federal agencies. The pattern inverted earlier epochs. In the 1950s, executives entered government. By the 2010s, generals were exiting into boardrooms, monetizing Rolodexes built on secret briefings and classified requirements. By the time the Afghan withdrawal began in 2020, the United States had spent an estimated $2.2 trillion on war-related appropriations, of which auditors calculate at least $900 billion went to contractors. Drones had become ubiquitous, cyber commands a co-equal combatant force, and the line between software startup and defense supplier paper-thin. Palantir ran intelligence fusion cells, Amazon's cloud housed CIA data lakes. The post-9/11 era thus entrenched a multi-tiered complex in which the state served as anchor customer, private firms supplied both trigger and trigger finger, and war itself became a platform serviced by a global, mobile, and immensely profitable contractor ecosystem. Since 2020, the U.S. military-industrial complex has entered a phase defined less by counterterror policing and more by an open, technology-centered rivalry with China. Internal Pentagon memoranda cite Beijing's DF-17 hypersonic glide vehicle test of October 2019 and its fractional orbital bombardment demonstration of August 2021 as the moment assured regional access could no longer be taken for granted. The response has been a rush to field new families of weapons whose supply chains sprawl across commercial technology sectors. Lockheed Martin's air-launched rapid response weapon and the Army-Navy long-range hypersonic weapon both depend on specialized thermal protection tiles produced by just two U.S. firms, themselves reliant on Ukrainian needle coke and Japanese furnace linings. A single shipping delay in 2022 forced the Air Force to slip an entire test window. Artificial intelligence race dynamics are equally entangled. The Joint Artificial Intelligence Center was folded in 2022 into the new Chief Digital and Artificial Intelligence Office, which now oversees over 600 projects ranging from predictive jet engine maintenance to Project Maven's target classification algorithms. Training data sets sourced from commercial satellite constellations, Planet, Maxar, BlackSky, move under embedded commercial services contracts that grew 47% in the 3 years after Russia's invasion of Ukraine, suggesting that the line between civilian Earth observation and strategic collection is dissolving faster than export regulations can keep pace. Supply chain fragility has thrust semiconductors into the center of defense planning. A modern F-35 contains more than 5,000 chips fabricated on Taiwanese and South Korean lithography lines. The Commerce Department's 2022 CHIPS and Science Act appropriated $52 billion to reshore at least part of that capacity, but the first TSMC and Intel security fabs in Arizona will not reach volume production before 2025, and even then only at the 4-nanometer node, 2 generations behind what commercial phones will use. Meanwhile, China has announced its own third big fund, injecting another $45 billion into state-backed semiconductor plants in Wuhan and Shenzhen. The Pentagon's Trusted Foundry program tries to mitigate espionage risk by placing classified chip masks inside secure modules at commercial fabs, but the Government Accountability Office warned in 2023 that fewer than 10% of all defense-grade microelectronics enjoy full end-to-end provenance. Fiscal politics impose contradictory pressures. The fiscal year 2023 National Defense Authorization Act authorized $858 billion, a real dollar record, yet rising Treasury yields mean interest payments already exceed the base defense budget. The 2023 debt ceiling standoff produced the Fiscal Responsibility Act, which caps discretionary growth at 1% through 2025 unless Congress designates additional emergency outlays, a loophole likely to push even more spending into the opaque overseas contingency or inflation adjustment accounts. The Congressional Budget Office projects that, absent new taxes, interest, Social Security, Medicare, and defense will consume every dollar of federal revenue by 2033. Hawks argue that cutting procurement would forfeit the Indo-Pacific balance, while budget hawks note that the Navy's 30-year shipbuilding plan envisions 376 manned vessels yet historically delivers barely half of its schedules. As inflation hovered around 7% in 2022, the Army was forced to delay its optionally manned fighting vehicle competition because bids busted statutory cost caps set only 18 months earlier. Civil military oversight is adapting to new ethical fault lines. After a 2020 revolt by Google employees killed the company's participation in Project Maven, Deputy Secretary of Defense Kathleen Hicks issued the Responsible AI Strategy and Implementation Pathway, mandating algorithmic audit trails, bias testing, and human override switches for all autonomous systems beyond Technology Readiness Level 6. Yet classified programs such as the Air Force's Collaborative Combat Aircraft continue under rapid acquisition authorities that waive many reporting requirements, prompting civil society groups to petition for a Geneva-style treaty on lethal autonomy. The Senate Armed Services Committee has asked the national academies to report on fail-safe architectures no later than 2025, but the interim period will see prototypes flying with only internal review boards for guardrails. Climate security adds a further layer. The Pentagon's 2021 Climate Adaptation Plan called climate change an existential challenge to U.S. force posture, and subsequent budgets include microgrid demonstrations at 39 domestic bases, experimental sustainable aviation fuel blends for KC-135 tankers, and a directive that new Navy vessels achieve 40% emissions reductions by 2035. Nevertheless, the Department of Energy estimates that DoD facilities consumed 83 million barrels of fuel equivalent in 2022, more than Portugal's national total, making any meaningful carbon pivot contingent on technologies, green hydrogen, modular nuclear reactors, that remain at pilot scale. Space has become both sanctuary and battleground. The Space Force's 2024 request tops $30 billion, with the Space Development Agency's low Earth orbit transport layer contracting thousands of small satellites from SpaceX, Northrop Grumman, and York Space. These mesh networks promise missile warning coverage under 10 seconds but also hand the commercial launch market a de facto subsidy. China's Shenzhen 21 on-orbit servicer and Russia's repeated co-orbital tests have driven DARPA to revive Project RSGS, an autonomous satellite repair robot, underscoring the shift from one-off exquisite satellites to agile constellations designed to survive kinetic and cyber attacks. Taken together, the next decade presents a paradox. Strategic rivalry with China, technological discontinuities in AI and hypersonics, and climate adaptation imperatives demand unprecedented innovation, yet fiscal ceilings and ethical crosscurrents threaten to fragment consensus. The military-industrial complex that emerged from the Second World War now finds itself negotiating not just the speed of procurement but the moral and ecological parameters of national survival, even as the boundary between civilian commerce and martial power all but disappears.